How's it going, everybody? It's kind of bright here. Yes. Woo! Yeah. I know it's 5 p.m. Everybody is a little bit tired, and everybody is waiting for Mistral. But before that, okay, I wanted to talk to you a little bit about vector stores. And actually, I was supposed to have a presentation with Stephane, but I might have told him that the conference is tomorrow. No one really wants to hear about Milvus. Everybody wants to hear about Postgres, I assume, right? Yeah, there you go. Okay, so presentation is just with me. Awesome. A little bit about me. I'm Raouf Shebri. I'm a developer advocate at Neon, and I wanted to talk a little bit about myself. So the next slide is me skiing. Okay, so I love skiing, and I discovered the sport about 6 years ago, so quite late in my life, but I love it. I try to go every weekend, and as every skier, sometimes you get into accidents, right? And this one was a pretty good one. I broke my arm. I broke both bones in my forearm, and now I have to live with these bad boys for the rest of my life. But that's great. But it was actually quite a challenging experience mentally, more than physically, although I had to hold my hand for a couple of hours at a hospital. But I tried to overcome the experience, so what I did is that I went skiing the next week. Even with the cast, I didn't care about it. I was like, okay, let's just do it, because I love this, and I'm not going to have a broken arms standing on the way of me and skiing for a couple of hours. So I guess the lesson here is life is short. You should do what you love, and yeah, you should do it now. And the other lesson is anything worth pursuing is hard anyway, right? So just go in and do it, fail again until you get it right. And I guess these lessons translate pretty well to the development work. And I think, like, as developers, we like to use technologies that we love, and we fail all the time using them. And sometimes when we build stuff, it's hard, but we should keep doing the same. All right, and speaking of things that people love, developers love Postgres, right? Do we have any Postgres users here? Yeah, I love it. Nice. Okay, by the way, it was about 70% of the audience for people who haven't seen, but yeah, awesome. And arguably, Postgres is the most popular database in the world because, well, the Stack Overflow survey says it. Almost half of developers use Postgres. And for me, I see Postgres as, I think if it were a car, it would be a Porsche. And the reason being, wait. I have a logical explanation. I think that Porsche has figured out the design a while ago. And then they just kept the same design and reiterating. And I think Postgres has done the same. So the database has been around for almost 40 years, and it's been evolving to meet the modern era, and that's great. So, but scaling Postgres can be hard. And this is why at Neon, the company I work for, we built serverless Postgres. And what serverless Postgres does is it scales up and down. It scales down to 0. It stores in a custom storage engine. It's multi-tenant. And you get everything that you love about Postgres, but in the cloud. And let me show you actually an example here. This is what Neon looks like. And one of the things with the separation of storage and compute is that we can create projects really fast. So it takes less than a second to set up a Postgres database. And anybody who set up a Postgres database before could appreciate how fast this is. And you get a connection string, and you can play with it. And I have here other projects that I can show you. But I can just skip this one. And we added a bunch of other stuff to it. So one of the things that we added in addition to fast starts, it is features like branching. And branching is copying your data. It's creating a copy of your data. So just like what you do in Git. Who here uses Git? GitHub? Nice, okay. So whatever you can do with Git, kind of we're trying to do the same thing, but for databases. So you could create a branch and use it for development, add new features, give it to your marketing department. and it's safe and isolated. And I'm going to show you, and it takes the same amount of time to actually create a branch. All right, but as I said, to meet the demands of the modern era, we need to make Postgres, make Postgres be usable in the AI world. And one of the ways to do it is through vectors. And let me show you this app here. So vector databases gives you the ability to understand the meaning of a text. And let me show you how. Okay, so I need to play a little bit with this. Okay, so what you can do, so here I have an example of an application where I can chat with my PDF. And traditionally, what you would do, you would maybe copy the content of that PDF, add it to your prompt, and ask your questions, and then you get those answers. But the problem with that is that sometimes the text maybe doesn't fit in the context window. And sometimes, because that text is so big, it contains unnecessary information, which increases cost. So how can we make it more efficient? Well, vector search is a way to get the text that you need based on the meaning of your question. So let me get that, and let me explain what we do here. So when I upload my PDF file, what we're doing under the hood is splitting this text and creating associated embeddings. And I know you heard this term over and over today. So who's here is familiar with vectors and embeddings? So just to see, okay, all right. Unnecessary part. You should have told me. We could have saved 3 minutes now. No, just kidding. All right. So I'm going to skip this part about vectors and vectors embeddings. But basically, for those of you who don't know, so vectors are just a series of numbers. And if you want to know how similar vectors are, we calculate the distance between vectors and see how similar they are. But how do they apply to text? Well, here I have a quick example of a few words, of word embeddings. So for example, I have the word orange, apple, dog, and cat. Now, let me go back to my database just to show you that actually in this project here, when I uploaded my PDF file, so I have my chunk of text that are associated with these vector embeddings, right? So each weight in that vector embedding is a correlation to a characteristic, right? So here, for example, the word orange is unlikely to be human, but it's very likely to be fruit or a color. And the same applies to apple, dog, and cat. And with this, we can kind of plot those vectors in a multidimensional plane, and we can know which words are similar, or texts are similar in this case. All right, and the vector vector search has become so important in the world of databases that everybody, all the major databases have implemented this feature, going from open source to closed source, and you have even dedicated vector databases nowadays as well. So, okay, all right. I guess I shouldn't have big the slide, but I guess the question is, which vector database you should use? Well, it depends, right? Thank you. Yes, it depends. Well, it depends on your use case, on your data set, size, how many dimensions you're using. But you know, in my world, we say just use Postgres. So I just wanted to recap all of this by actually, I wrote a little speech. Can you replay the music, please? Maybe we can replay the music? No? Thank you. All right. So ladies and gentlemen, Postgres is one of the most popular databases today. But don't take my word for it. According to the Stack Overflow survey, Postgres has surpassed MySQL for the first time as a database of choice among developers. And here's why. In a world obsessed with shiny new technologies, Postgres has stood the test of time over and over again for over 40 years. Thanks to its reliability, extensibility, and vibrant community of hackers and developers, Postgres has been consistently improving on its design. If it were a car, Postgres would be Porsche. The iconic car manufacturer perfected its design decades ago and has been innovating without compromising its core values. Similarly, Postgres created the perfect, most versatile database for organizing structured data decades ago and has become the gold standards. Ladies and gentlemen, Postgres is the Linux of databases. It's truly open source and is now more than just a relational database. With its robust ecosystem of extensions, Postgres has expanded its capabilities to meet the demands of the modern era. Things like JSON, geolocation, and now in the era of AI, vectors. Vector embeddings are mathematical representation of meaning. Each value in a vector represents a correlation to a characteristic, capturing the essence of text, of images, of data. Ladies and gentlemen, this unlocks a new way of searching called semantic search. This type of search doesn't just look at keywords, it understands the meaning of the words. For instance, with the vectors, the search for happiness can result into joy, into contentment, because the system now understands relationships, context, and emotions. And isn't that beautiful? This ability allows AI applications and large language models to extend their knowledge beyond the dataset they were trained on, making it more insightful and more powerful. No more hallucinations. I'm almost done. Vectors enable developers to build smart apps. From AI-powered chatbots to search engines, vector embeddings bridge the gap between raw data and understanding. Vectors empower developers to create new experiences where data isn't just shared, it's made meaningful. So the message is simple. Just use Postgres. It's timeless, reliable, and consistently evolving to meet the needs of today and tomorrow. Thank you.
All right. Hold on. So you're just like, yeah, use Postgres for everything. But there's some problems, you know, it's not only beautiful.
All right.
We have other problems. Can you move off stage, please?
Sure.
So you say, okay, just use Postgres, and that's cool. But, you know, like it's estimated that 90% of the data in 2025 will not be structured data. So that's cool, but, you know, it's time to move on. We're like, you know, and also, you know, you mentioned embeddings. A lot of people talked about embeddings today, but what about high-dimensional embeddings? What about indexes? You know, people always go for the things by default, but there are lots of different embeddings. What about performance at scale? You know, you said it yourself, scaling Postgres is hard. How are you going to do that with vectors? Also, what about GPUs? Are you going to use GPUs? You know, we had a good talk by NVIDIA. We have lots of different GPUs providers as well. So can you do that with Postgres? I don't think so. And if you have a look here, this is the leaderboard of Hugging Face. This is the top 10 embedding models for English on various tasks. You can check one thing, and one thing only. It's the dimensions of the embeddings. If you look, and I hope you can see in the back because it's pretty small, but I'm just going to tell you, most of the embeddings, the dimension is more than 4,000. As far as I know, and you tell me, Raouf, right? But Postgres and PostgVectors don't support that, right? Other mic?
Yes, there's a limit of 2,000 dimensions in Postgres, and this being the page size in Postgres is by design 8 kilobytes.
Okay.
And one float is 4 bytes. So yeah, 4 by 2,000, that's 8 kilobytes. So there's that limit.
So yeah, so 9 of the top 10 embedding models are not supported. So yeah, that's cool, but maybe it doesn't work, you know. And embedding models are like very important, but I also want to insist on something is that, yes, I've shown the leaderboard. Yes, if you're going to look for embedding models, maybe you're going to go for the first one. Just as a reminder, choose an embedding model that fits you, that fits your use case. I'm based in Berlin. I work a lot with German documents. If I pick the best embedding model there is, it's likely going to be shit because it's trained on mostly English. If you go for OpenAI embedding models, it's trained on like 90% English. As far as I know, Mistral Embed works only with English. Tell me if I'm wrong, but it doesn't really support German. So like those are the things you have to look into. Sorry, really have a look in your use case. So maybe Postgres can work, but maybe it won't. And yes, I'm Stephane. I was supposed to not be here. I was in the back. That was the most cringe entrance I've ever done in my life. But it's my last talk of the year, and it's the 34th, so I thought we would do something funny. And yeah, I work for Milvus and Zilliz. We are an open source vector database. And today I'm here to talk to you most about what I talk with my customers and with the people that are using actually vector database, and they might start with Postgres. And don't get me wrong, Postgres is amazing, but sometimes you have some limitations. And the goal of my talk is basically to mention those. So what started as like happy beginnings, maybe you showed V0, or you showed something generated by V0 maybe.
Haven't.
You showed like a basic app that you can do with V0, and then you're going to be happy, you're going to like select Postgres, you install pgvector as the extension, and then everything's happy. And then you publish your app on the internet, and people start to actually use your app. So you start to have more users, you start to have more data, which means that you're going to have more and more pains because, as we mentioned before, maybe, scaling is going to be hard for Postgres. Maybe sharding will be hard and things like that. So yes, you have more and more data, and your search quality is declining. Your index is taking forever. At the beginning, you were happy. You were adding 10 documents. You were adding 20. You were adding 100. It takes about a couple of minutes. Then it takes about an hour. Then it takes like a couple of hours. You have to update your index on a Saturday evening, praying from midnight to 7 a.m. that it's going to work. And if it doesn't work, then you will actually not have this data anymore. So then you start to be very, very frustrated. And so you start a new game then, which means you're going to start from scratch again. But this time, you're going to think a bit before, because you're just not going to go with the default one, but you're going to have a look at the different parts that you have for vector search. Actually, we usually talk about vector database, but there are a lot of other parts. So as I've mentioned, you have a look at the embedding models. Please, again, as a reminder, don't pick the first one just because they're first. Really have a look at what's going to happen. But you take one that fits your use case, and then you're like pretty happy with it. Then you're going to look for a vector database. You're going to look at benchmarks. And you're going to go maybe on one of our competitors' Quadrant's website. You look at the benchmarks. Surprisingly, they're first. You look at our website. Surprisingly, we are first. You look at Weaviate website. Surprisingly, they are first. So every vendor is first. On benchmarks, so I always tell people, don't look at the vendor's website, because everyone is saying, yeah, our benchmark is open source, and we're not biased, but everyone is. So yeah, just for benchmarks, two things I would say. There's one website which is called ANN Benchmarks, which is fully open, and you can see every vector database vendor. We create PRs, and then we run benchmarks, but it's like, it's fair to everyone. So have a look there. And then, to be honest, try with your own use case, because benchmarks, we do them on like something very specific, on a specific data set with like specific embedding models, which might be very different to your use case. So just try with your own, see if it works. Maybe you're going to do, I don't know, hybrid search. Maybe you're going to do full text search. Maybe you need to do partitioning because you have a lot of customers in different countries and so forth and so on. So have a look at yourself and don't really trust our benchmarks. Then you have a look at, you learn that, yeah, indexing, you have lots of different indexing. The default one usually on most vendors is HNSW, which is the second one in the row. And you're like, okay, I want a high accuracy, obviously. I want low latency, obviously. But index time, for example, for this one is very slow, because you need to build a graph every time. And so depending on your use case, it's actually quite important to choose an index that will suit your needs. So if you need to like update the index very often, well, then maybe you don't go for HNSW because you need to build the graph all the time. But maybe you also don't need real time. It's fine if you the result takes like 400 milliseconds or something to come back. Then maybe you can use on disk, so disk ENN. And then this one has like a high accuracy, but a very high latency, and it's very slow to build. But it's very cheap because everything runs on disk instead of running in memory. So just have a look, and don't be scared. They always have like very, very fancy names, very scary names, but usually they're fine. And maybe you want to talk about HNSW for Postgres.
Yeah, so pgvector has support for HNSW, and it works pretty well for certain workloads. And but what you need to understand is that, obviously, I think I love Postgres and pgvector, but the limitation here is that you create the index in memory. So you need to be careful. When I said like the two main criteria would be the dataset size and your use case. So if you have a dataset size that is not going to fit in your memory instance, then you're gonna have a painful experience building the HNSW index.
So yeah, basically, try to have a look and try to think a bit before. And then you're gonna have a look at quantization. It's a compression technique. It's getting quite late. I won't explain it, but it's just like to transform float into ints. So then you have like a size reduction, which means that you have a storage reduction, which means that it might be faster and cheaper. And then it continues, basically, now you have a better index, you have a better data structure, and you also had to look at compression techniques. So maybe you want to be distributed. So then that's why, like have a look at different databases, in particular vector databases, to know if you need to go distributed or not. And more, there's partitioning, there's horizontal scaling. Do you need real-time as well? Do you need to have access to real-time data, to real-time vectors that are happening? Because maybe, I don't know, you talk about something about news and you need real-time updates. Or also monitoring. And yeah, basically, it never stops. And that's why we exist. That's why, like, we're not here just for funsies. Like, it's actually to solve those problems and to really help you here. And yeah, as I said, I work for Milvus, so that's why we exist. And you mentioned that, so Postgres is more like Porsche, they like figure out the design. They're German, so they always have this thing of like, why change it if it works? That's why they still use fax machines in Berlin. It's not a joke. It's actually, they still use, if I remember correctly, 5,500 fax machines in Berlin. But yeah, why change it if it works? For us, we're a bit different. So it was created in 2019, and you can see Milvus kind of like as a Formula One. So you can check the open source benchmark, that is not ours, to see that we're fast. But also, we have a lot of tweaks, it's not, there are a lot of things to take into consideration to really have optimal performances. To give you an idea, tell me if I'm wrong, but Postgres supports 2 different types of index. We support 15. So it's like, okay, maybe have a look at what you want, what you need. Maybe you actually want to do like GPU vector search. So then we support like GPU indexing. Or you want to support index on disk, then we also have it. Support different type of search, different type of compute as well. We work with NVIDIA, we work with ARM for like, on the edge. And then you have a lot of different computes as well possible. That's the architecture. So it's fully distributed, meaning that usually you would like scale up and add more RAM, for example, to your database. For us and for like other vector databases, usually it's like you scale up only one part of your infrastructure instead of like scaling up everything, which means maybe you have a lot of users suddenly which are querying your database, so you can scale up the query node and not the rest, because you don't need to. So then you don't need to like add RAM everywhere. And yeah, we have like fully distributed search, so that's magic. It works beautifully. But yeah, you don't have to think about it, so that's way better. And I mentioned at the beginning what scale. So for us, the scale we're talking about, on one instance, it's 10 billion vectors. And if you go distributed on Kubernetes, it's 100 billion vectors. And I'm not saying that, yeah, we tried, no one is using it. That's our customers. One of our customers has actually 100 billion vectors. and then run it in production. So that's the kind of scale we're talking about, or that we're capable of. And enough yapping. I also have a demo. And for my demo, usually I give a lot of talks, and I am very tired of giving demos with like, I don't know, 300 vectors. So we're going to go a bit bigger. And if we could change the mic to the pupitre, that would be amazing. Otherwise, I can just continue that way. It's fine. So I have a notebook here that you should be able to see. I'm going to skip. So I'm just, for transparency, it's not running on my laptop. You will understand why very quickly. Merci. So yes, so I'm just connecting to my database, and I'll just show you some stats, just so you understand why I don't run it locally. So this collection is running on a cloud offering. It has 483 million vectors. That is, I can't run that locally. You'll see the storage that it takes. It's a bit crazy. But yeah, so it's a very big collection, and the data set is lay on 5 billion, so it actually has 5 billion vectors. 5 billion is a lot, it's very expensive. My company wouldn't allow me to do it, so I do it on 500 millions. And so I built it, and then I'm just showing, you know, I have an index that is built on it. It's actually indexing close to 500 million rows, and it's called an auto-index. That's just something that we have that we decide automatically if we want to go for HNSW or disk, depending on your needs, depending on the data, so you don't have to like think about it. And yes, the data set, it's lay on 5B, sorry. It's basically used to train models as well. And what I want to show you is I want to show you the capacity, like how many query per second we can have. Because I am a bit tired of people showing things for like maximum 1 million, and then, you know, like everything is beautiful in a small world. This one, we're going to go a bit harder. So showing, those are the embeddings. So the dimension would actually fit in Postgres. Its dimension is 768. The problem now is that 500 millions, I don't think would work. And I'm just going to show, so I don't care actually about the results. What I want to show you is the maximum amount of query per second I can have. So I'm just going to go do like a vector search here, and I'm returning 100 vectors, and then I'm just going to show you actually the numbers. So what is happening now, and I can have the mic again, thank you. What's happening now is that basically in my collection of 500 million vectors, we are doing batch search. So I'm just first searching through 100 vectors at the time, then a batch of 500, then a batch of 1,000. And you know, you can see like it's happening. I'm getting some results. We're happy. You know, we live in a very beautiful world. And yeah, I have like, you know, we're going through 500 vectors, then we're going through 1,000. And what I want to show you is, I'm going to show you the metrics. Because I said I couldn't run it locally. You will understand why here. First, I'm going to hide that. Metrics. So I have, where is it? No, it's here. Yes. So I have about 10 terabytes of storage. So that's how much it takes for, you know, to actually have 500 million vectors, which is why I can't run it locally. So yeah, run it on our cloud. And then we should have actually quite high latency. I'm very disappointed. But basically to show you, to go through like, you know, those 500 million vectors and to get to search 500 vectors at a time or 1,000 vectors, surprisingly and sadly, our average is 106 milliseconds. So that's what we do, you know, like we search through those 500 millions, obviously optimized, and then we give you a result for the 1,000 vectors in 100 milliseconds. So that's the kind of scale we talk about. And that's our kind of speed. And I can show you here. Yes, it's over. So here, basically, I can run, you know, maximum of about, I get about 240 query per second, meaning that, you know, then if I search through 500 vectors, then it will be extremely quick to get 200 times 500 per second. And that's the kind of scale we have, and that's the kind of scale we're capable of. And that's usually why we also exist. It's like, it's a bit more complicated than just running vectors and just like, doing it on like very small scale. We and others can also be capable of, running on like 500 millions, a billion, 100 billion, as I've said before. And yeah, I want to add something as well. Maybe you have a lot of money and you raised a lot of, a big round. I see Jan, looking up. Yes. We also have GPU vector search, which is one of my favorite algorithms, actually. So it replaces HNSW for CPU and then instead using GPU. And I just want to flex some numbers so you have an idea, actually, of what's possible as well. So if you do like a search batch with the size of 1, if you go for CPU, which is the first one, you arrive at like 600 query per second. If you go for GPUs, you arrive at about 5,000. Given that GPUs are really good at like doing search in batch, really big batch, then we can also increase it. So if we increase it to 100, we can see that we arrive at 32,000 query per second, while the CPU is still stuck at 659. So that's like the kind of thing that is also possible if you have really important use case and you need to be extremely quick, extremely fast, and you need a lot of query per second. We also have GPUs. NVIDIA also did a benchmark. They went a bit, honestly, crazy. They did a batch size of 10,000 vectors. And if you want a very good recall, so we're just going to focus on the right here. If you want like a recall of 0.95, they get more than 1 million query per second. Whereas if you're on CPU, you're at less than 100K. And that's what's possible as well when you go really at scale and if you want to use GPU vector search. And yeah, just want to say basically we like came together and it's not a war, it's not like you have to choose one or the other. It's more like, yeah, we just like it's more collaboration.
Yeah, I guess today's talk is not about Milvus or Postgres. So anybody who's built data pipelines knows that you need to have multiple databases, and the best database is always the one that fits your use case. So you have something to say about that?
No, okay. Basically different paths and same destination, sorry. Maybe just as a conclusion, how to select a vector store?
Go ahead.
So yeah, depends on your current infrastructure. Which one do you use? Which database do you use, as you said? So the use case.
Yeah, so when it comes to about your current infrastructure, so maybe if you have a small data set and you already have Postgres, so you can, and you want to be exposed to vector search, then you can start with that, right? And then you see, does it fit your requirements? Does it fit your use case? How many dimensions do you need in your embeddings, right?
Yeah, and then, use case, so like for the embeddings, as you said, and then which index do you want to use, It's like, do you want to fit everything in memory or not? What are the query latency requirements as well? Do you want to be very fast?
Exactly.
Or you want to be like, Porsche is not slow, but in comparison to Formula 1, it's a bit slower. So maybe, like you want to have a look at those. And yeah, dataset size. Can you handle sharding yourself? Can you?
Yeah, that's one of the questions that he asks yourselves. Like, there are many ways to do sharding. Milvus does it out of the box.
Yes.
There are some other Postgres solutions that do that. But then, so basically, do you have the right personnel? Do you have the right technology? Do you have the right service provider when you make those kind of choices?
Yes. And do you want to go open source or not as well? That's a big one.
Of course, yes.
Of course. We're not biased. And yeah, that's how we would say how to select a vector store. And yeah, that's it. Thank you.